All right, this is section 3-4, parallel and perpendicular lines. Again, let's start off with reviewing some vocabulary. All right, so a transversal blank intersects at least two lines. So a transversal will always intersect at least two lines. A transversal blank intersects two lines at more than 1 point. Okay, so a transversal will only ever cross at 1 point. So this is never true. A transversal blank intersects two parallel lines. A transversal will sometimes intersect two parallel lines. And a transversal blank forms angles with two other lines. Will always form angles. Okay. All right, so what is transitive? So transitive, some related words are transition, transit, or transitivity. So you use the transitive property in proofs when what you know implies a statement that in turn implies what you want to prove. So the example of transitive, if I know A implies B and B implies C, so notice the relationship here is B, then I can jump and make the conclusion that A must have also implied C. So the transitive property describes a property where one element in relation to a second element and a second in relation to a third implies the first to the third. Okay, so let's use our vocabulary. If A is greater than B and B is greater than C, then what do I know? Well, then I know A must be greater than C. If Joe is younger than Ann and Ann is younger than Sam, then what do I know? I know Joe is younger than Sam. If you travel from station 2 to station 3 and you travel from station 3 to station 4, then you travel from station 2 to station 4. Okay. So, theorem 3-8, transitive property of parallel lines, and theorem 3-9. So we're going to complete the two charts here. So, theorem 3a, transitive property of parallel lines. So if I know two lines are parallel to the same line, then they are parallel to each other. So if A is parallel to B and B is parallel to C, then I know A must be parallel to C. Similarly with perpendicular. So in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So M is perpendicular to T, N is perpendicular to T, so they're perpendicular to the same line. Then that means M and N must be parallel. Okay. So let's solve a problem with parallel lines. Okay, so can we assemble the pieces at the right to form a picture frame with opposite sides parallel? So circle the correct phrase and complete the sentence. To make a picture frame, you will glue two different angles together. If I glue the same angles together, we're going to get something weird. The angles at each connecting end measure what and what. So I'm going to glue a 60 and a 30 together. When the pieces are glued together, each angle will form 90 degrees. So complete the flow chart here. So this is going to start from left to right. So the top and bottom pieces will be perpendicular to the side pieces. The left piece will be parallel to the right piece. The top piece will be parallel to the bottom piece. So opposite sides are going to be parallel. So underline the correct statement here. Can I or can I not assemble the pieces to form a picture frame with opposite sides parallel? Yes, I can. All right. New theorem, theorem 3-10, perpendicular transverse theorem. So in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. So number 14, place a right angle symbol in a diagram at right to illustrate 310. So I know N is perpendicular to L, but I also know L is parallel to M. Therefore, I know N is also perpendicular to M. All right, so using the same information here. two parallel lines. We know A is perpendicular to T. So A is parallel to G, given in the picture. I know A is perpendicular to T. So therefore, G must also be perpendicular to T. And then I can put a symbol if I wanted to. All right, so here's another illustration. So I know C is perpendicular to N, and I know N is parallel to P. So I know C is perpendicular to P. All right. So problem 2. Use the diagram at the right and in the plane, we know that C is perpendicular to B, we know B is perpendicular to D, and we know D is perpendicular to A. Can I conclude that A and B must be parallel? All right, so circle the lines that are perpendicular to A. So we only know that A is perpendicular to D, because they're right here. All right, underline the line that's perpendicular to B. Okay, so A, underline this part, so which one's perpendicular to B? Well, they're there, B and D. So that one's for both of them. So lines that are perpendicular to the same line must be parallel. So there we go, there's our proof. Okay, so yes. All right, so lines A and B are both perpendicular to line D. So A is parallel to B by theorem 3-8. Okay, so in one town, Avenue A is parallel to Avenue B, and Avenue A is also perpendicular to Main Street. How are Avenue B and Main Street related? Explain. So 20. Label the streets in diagram A for Avenue A, B for B, and M for Main Street. All right, so this has got to be A, this has got to be B, this has got to be M. Good. The perpendicular transversal theorem states that in a plane, if a line is perpendicular to one or two parallel lines, then it is also perpendicular to the other. So Avenue B and Main Street are perpendicular streets. So I can actually put in a symbol here. Okay. So we're going to use the theorem of postulate from early in the chapter to support this conclusion to 3-9. Okay, so complete the conclusion. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. All right, 23. If two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So complete the conclusion. In a plane, if a line is perpendicular to one or two planes, then it is also perpendicular to the other. Okay, so explain how the congruent angle pairs formed by parallel lines support the conclusion of the perpendicular transverse theorem. So one possible answer here, if both alternate interior angles are right angles, then the line perpendicular to one parallel line is perpendicular to the other parallel line. All right, and that's the end of the section. You should have these words pretty well understood by now, and that's the end of the section.